Alright, here we go, guys. Sequences 1.8. So, first thing we're going to do is we're going to find the missing values for each arithmetic or geometric sequence. Determine if it's a constant difference or constant ratio, or common difference or common ratio. We also use those phrases. State the value of that difference or ratio, and then determine which one it is, arithmetic or geometric. So, let's get going. So we look at this one, 5, 10, 15. Should know that that's going to be 20, 25, 30, 35. So is it a difference or a ratio? Well, difference is when we're adding or subtracting the same number. Ratio is when we are multiplying by the same number. So definitely a common difference, okay? And that would be plus 5, which would make it arithmetic. Okay, number 2, 20, 10, something, 2.5. So I believe 5 would go here, then 1.25. Okay, so it's being cut in half each time, or in other words, dividing by 2, which would make it a ratio. So we could say divide by 2, or we could say times by 1/2, same thing, which would make it geometric. Okay, number 3, 2, 5, 8. Okay, so it looks like we're adding 3, 11, 14, 17. Common difference, add 3, it makes it arithmetic. 30, 24, something, 12, 6. So here we're subtracting by 6, aren't we? Okay, that would be 18, which makes it, again, common difference, which would still mean it's arithmetic. Alright, now we're going to take a look at these patterns and determine if they're arithmetic or geometric, and write the equations. Now remember, regardless of whether it's arithmetic or geometric, we always start a sub n equals a sub n minus 1, a sub 0 equals, and for the explicit, a sub n equals. Okay, so we know regardless that we're going to do that. Okay, so 2, 4, 6, 8, 10, 12. Should be able to see that we're adding 2 each time, making it arithmetic. So we add 2. And then to go back to the 0 term, that would actually be 0 in this case, wouldn't it? Because 2 minus 2 is 0. So for our explicit, we start with 0, we add 2 n amount of times. Okay, number 6, 2, 4, 8, 16. This one's not the same as before. This time we're timesing by 2. Makes it geometric, so times by 2. Going backwards, 2 divided by 2 is not 0, it's 1. So we start at 1. So I start at 1 times by 2. Repeated multiplication means I make the exponent. Okay, now let's do the same thing, but this time with the table. So again, a sub n equals a sub n minus 1, and a sub 0 equals for my recursive. And a sub n equals. Alright, remember, because that's what we always put in there, so I can always start out by doing that. Just a great way to remind myself that it doesn't matter if it's explicit or recursive, or not, if it's arithmetic or geometric, because if it's explicit or recursive, it does matter. But if it's arithmetic or geometric, it does not matter. And then all it comes down to is finding how it grows and where it starts. And if it's arithmetic or geometric, that just determines how we deal with either adding or multiplication. Okay, so number 7. We go from 3 to 7, so that could be plus 4. Does that keep working as plus 4? It does, so it's definitely arithmetic. Going backwards to the 0 term would be negative 1. So start at negative 1, and we're adding 4. Start at negative 1, and we're adding 4. It's arithmetic, so times by n. Number 8, 5, 8, 12.8, 20.48. This one's kind of a little bit tougher. The easiest way you can do is to take 8, because I know it's not adding by 3 because we have decimals. So it's probably geometric. So if I go 8 divided by 5, I get 1.6. So if I go 8 times 1.6, that gives me 12.8. So I'm multiplying by 1.6. And then if I go backwards, so 5 divided by 1.6 gives me a starting number of 3.125. So we start at 3.125, multiply by 1.6 to the n power, because it's geometric. Okay, number 9. Michelle likes chocolate, but it causes acne. She chooses to limit herself to 3 chocolate bars every 5 days. So she eats part of a bar each day, basically. Okay, so I would like to think of this as a table. So she starts herself off, okay, probably with 0 chocolate bars. Then that 5th day, she has 3, right? So what about these numbers in between? Well, we'd have to eat so much of a bar that we'd get to 3 after 5 days. So if I take 5 days and divide it by 3, guess what? That's how many we ate. So 5 divided by 3 would be about 1 2/3. So we would add 1 2/3 and start with 0. So 0 plus 1 2/3. And we're adding, so it's arithmetic, and we put an n there. Okay. All right, number 10. Scott decides to add running to his exercise routine and runs a total of 1 mile his first week. Okay, so we know we start with 1. He plans to double the number each week. Double, geometric, because we're times them by 2. So times by 2, times by 2, put to the n power here. Okay. Number 11. Vanessa has $60 to spend on rides at the state fair. Each ride costs $4. Okay, so she starts with $60, right? And then she's going to spend $4 each ride. So we would subtract 4 each time, right? It's arithmetic because we're subtracting by 4. So times by n. And our last one, Cami invests $6,000 into an account that earns 10% interest each year. Okay. Alright, I had to pause this video yesterday and I didn't quite finish it, so I'm not sure what the last thing I said, but we should be on number 12. So Cami invested $6,000 into an account that earns 10% interest each year. Okay, so typically when we're dealing with percents, you can pretty much bet that it's going to be geometric. Okay, and the easiest way to think about this, okay, because it's easy to find 10% of 6,000, right? We just times by 0.10, okay, which we would get 600. So then after the first year, right, she'd now have 6,600, assuming she didn't take any money out. Well, then to get to the next year, we'd take that and times that by 10%, and we'd end up with, 660, which we would add to that and get 7,260. Okay, the problem is we're having to multiply and add, but we're adding different numbers, but we're multiplying by the same number. So there's an easier way to think through this, okay? And the way we want to think through this is we want to instead think about, okay, so 6,000, because it's an investment, she's going to have that 6,000 in there, okay? Well, that 6,000 is 100%, right? And that first year we added 600, which was 10%. So we're adding 10% to the 100%, which gives us 110%. That's how much it's growing each year. So it starts out with 6,000, okay, and we're timesing by 1.1, 110%. If we do that, then we get the 6,600. And then we can keep multiplying, so our growth is timesing by 1.1, which represents timesing by 110%, okay? So times by 1.1, and we started with $6,000. So explicit a sub n, 6,000 times 1.1 to the n power. And that's how we deal with those kind of percentages, is thinking about if it's growing, how much more do we have, and going from there, okay? Well, there we go, guys. That's all we got on this homework.